A major difference between stats and maths is that stats does not usually answer questions with 100% certainty. Branches of statistics. Descriptive statistics is the branch that deals with summarization and organization of collected information. Survey deals with collecting information. Computational deals with calculations, and inferential deals with making inferences and predictions. Sample and population. Population is the entire set of individuals or objects in the study. Sample is a subset of the population. Example, you contact 182 American women in their 50s and ask them if they went out of state last year. What's the population? So the underlying population here we can see is all American women in their 50s. And remember, we never include the question part in the identification of sample and population. So in this case, B is the correct choice. And if we want sample in the above experiment, and again, the experiment was 182 women in their 50s, and we asked them something. So the 182 American women in their 50s, that's the sample, and that is choice B. Population parameter and sample statistics. A parameter is a numerical summary for population. Statistic is a numerical summary for sample. So remember, P goes with P, population parameter, and S goes with S, sample statistic. Example, the average height of all female college students in USA in 2006 was 64 inches. So 64 is a parameter because it deals with all the female college students in USA, and that is a population we are dealing with. But if we said, for example, the average height of 80 randomly chosen students, so average height of 80 randomly chosen female college students was 64 inches. So now we're not choosing all the female college students in USA. We are only choosing a sample of 80. So therefore, the 64 inches is information about the sample, and therefore it is a statistic. Discrete variables are those that can be counted. For example, number of students in a class, number of votes in an election. And then we said that in this course, even price and cost will be discrete variables. Continuous variables are those that cannot be counted, but can be measured. For example, length, weight, time. Sampling techniques, so the ones we'll study in this course first is convenience. That's a lazy person's approach. Systematic, where we use some kind of a system. For example, at an airport, the security might decide to search in depth every fifth person in the line, starting from the third person. Simple random, here we just randomly select a few individuals from the population. So to select 4 students from my class of 45, I can just write the names of all in a slip of paper, shuffle the slips, and randomly draw out 4. And that's simple random. So then stratified and cluster are 2-level samplings. In stratified, we divide the population into groups and then randomly select a few members from each group. So every group gets a representation here. Whereas in cluster sampling, we divide the population into groups and then only select a few groups and then every member from that group. So here, not all the groups get a representation, but whatever groups are chosen, there everybody from those groups get a representation. So then we say that all the sampling techniques that we have just discussed, they do sampling without replacement, which means that once an individual is selected, then the individual cannot be selected again. Lower class limit is the smallest value within the class. Upper class limit is the highest value within the class. And class width is the difference between consecutive lower class limits or upper class limits. For example, in this class, in this data, the number of classes is 4. We have 4 rows here. And for example, the lower class limit of second class is 170 and the upper class limit is 179. Frequency of second class is 1. So the number that fall in each class is the frequency. And then we make sure that the frequency table classes do not overlap. That way there is no confusion as to which class an observation belongs. So for example, if they were overlapping, then we wouldn't know. So like if this was 160 to 170 and this was 170 to 179, then we wouldn't know where to place the 170. So that's why, in order to avoid confusion as to where an observation belongs, the classes should not overlap. Cumulative and relative frequency. And so another thing to see is that the class width here is the difference between vertical entries. So the class width here, for example, if you can look these two consecutive vertical entries, 170 and 160, the difference is 10. So the class width is 10. Cumulative frequency of a class is the sum of frequency of that class and all frequencies of previous classes. So for example, in this frequency table, the cumulative frequency of the third class, so the frequency of that class is 2, the cumulative would be that and everything above it, so 2 plus 1 plus 3. So that's why the cumulative frequency of the third class would be 6 here. Relative frequency of a class is the frequency of that class divided by the total frequency. So for example, the relative frequency of the third class, the frequency is 2. So the relative frequency is 2 divided by 8 because 8 is the total frequency. If you add up all these numbers, you get 8. And so it's 0.25. And sometimes, so here we are expressing it as a proportion. So if we express it as a percentage, we can multiply these entries by 100. So then this third class relative frequency would be 25%, for example. And then all the relative frequencies have to add up to 1 if you're using proportions. So you can see they'll add up to 1. And if you use percentages, then they have to add to 100%. Histogram. So this is an example of a histogram in which the frequencies are represented along the verticals. The frequencies are the heights of the histogram and the classes are represented along the horizontal. So here, if they ask how many patients were sampled, we just add all the frequencies, 5 plus 11 plus 23, 24, 24, 9, and 4. And so we see the total frequency was 76. Therefore, the number of patients sampled was 76. And if we identify the classes and the frequency, so now in a histogram, in order to avoid the ugliness in the drawing, we write classes as overlap. So we wrote the first one as 1 to 5, second one is 5 to 9, third one 9 to 13, and so on. But we know that in a table, the classes should not overlap. So actually, if we were to represent these classes in a table, we will not say 1 to 5, but we will say 1 to 4. And similarly, the second one, we will say 5 to 8, and so on, 9 to 12, and so on. Which class has the highest frequency? The highest frequency is 24, and the class that's causing this is 13 to 16. Remember how we read the classes as if they were to be written in a table. And what is the class width? So in a histogram, we have no choice but to read the class width in a horizontal way. So we would do 5 minus 1, that's 4. Similarly, you can subtract any 2. But remember that we do only in a histogram. In a table, remember, we do it vertically. So here the class width is 4, 5 minus 1, for example. And the lowest frequency is this one, and that is 4, and the class that has the lowest frequency is 21 to 24. What percentage of patients had age at least 13? So 13 starts from this bar. So we just basically, at least 13 means 13 or more. So we just add up all the ones starting from here until the end. So 24 plus 9 plus 4, that would be 37. And then this is the number of patients whose age is at least 13. To find the percentage, we divide this number by the total. Remember, total patients were 76, so 37 divided by 76, and then we time it with 100. So it's 48%. And then we have the types and shapes of distribution. So this is a symmetric distribution where mean is equal to the median. So symmetric means symmetric about the center. And this is a right skewed distribution here. The tail happens on the right and the peak happens on the left. And this is a left skewed distribution where the tail happens on the left and the peak happens on the right. So in a right skewed distribution, mean is greater than the median. In a left skewed distribution, mean is less than the median. And this is an almost uniform distribution. In a perfectly uniform, all the bars should be of the same vertical height. But if they are about the same, but not exactly the same, we still call it symmetric. And here we can see how to read the shape of a distribution from a stem and leaf plot. So, for example, these are the values 67 through 100. So we can represent them in a stem and leaf plot like this. So first stem is 67, and then we write a 7 here, and the second stem is 7. And with that, we have 73 and 76. So the important thing here, so here there's a bit of an error in the choice that is being marked here, but the important thing to see is that this is an example of a symmetric distribution, because if we were to draw a picture like this, this would be symmetric, because you imagine just rotating the picture. So imagine this. So if we were to just rotate this picture, let's try rotating it. So you see here, so now we see that this is a symmetric distribution, because this was the starting point and this is the ending point. So even from a stem and leaf plot, you can see what the distribution looks like in shape. Pie charts. So this is an example where you have, so this in reality is the pie chart, where we know that the total degrees is 360 degrees. So this is a different kind of a picture. So for example, if you have this question, an undergraduate freshman, so here I think the thing got disturbed because of the moving around. Okay, so in a pie chart, the total 6 degrees is 360. So consider this: an undergraduate institution has 450 freshmen, 400 sophomores, 300 juniors, and 333 seniors. How many degrees on the pie chart are represented by the freshmen? So what we will do is we will have freshmen on the numerator and divide by the total. So the total is obtained by adding all the rest, and then we multiply by 360 degrees, and that gives us how many degrees on the pie chart are represented by the freshmen. And multiple bar graphs. This is a multiple bar graph, and here we can see that we have different categories represented by different bars. Okay, so mean, median, and mode symbols. So these are symbols which are the most important things in a way of this course, as lots of questions come about these symbols. So population mean is nu, population variance is sigma square, population standard deviation is sigma, sample mean is x bar, sample variance is s square, sample standard deviation is s, and then the summation symbol is this. Mode of a data is the most frequently occurring value in the data. Data may have no mode, one mode, or more than one modes. If all data values are different from each other, there is no mode. And then the mode of this data is 6, because 6 occurs the most. It occurs 3 times. Now, 7 is not the mode here, because 7 occurs only 2 times, whereas 6 occurs 3 times. So 6 is the mode. But in the next set of data, both 6 and 7 occur twice, and nothing occurs more than that. So 6 and 7 are both the mode in this second set. If a data has only one mode, it is called unimodal. If it has exactly 2 modes, it's called bimodal. Median is a value that lies in the middle of a data that has been arranged in ascending or descending order. If there are 2 values in the middle, then their midpoint is the median. So for example, if we have 3, 5, 7, 10, and 20, then only 7 is in the middle. So 7 is the median. And if we have 3, 5, 7, 8, 10, 20, then we see 7 and 8 are in the middle. So the median is the midpoint of 7 and 8, which is obtained by adding 7 and 8 and dividing by 2. So that's 7.5 in this case. Mean of a data is found by adding all values and dividing by their count. So the mean of this data is obtained by adding these and dividing by 4, and we get 59.5. So in general, mean, median, and mode do not have to be the same. However, it is possible for data to have same mean, median, and mode, and that happens when the data is symmetric. So for example, consider this one. The values are 3, 4, 5, 5, 5, 6, 7. So the mean obtained by adding them all and dividing by 7 is 5. And we can see median is also 5, that's in the middle. And mode is also 5. That's the most occurring value. But in general, they don't have to be the same, but they can be the same. Finding a missing data value when median is given. So in this one, we have 6, 8, 10, and then a missing value, and then 15 and 20. And we are told that the median is 11.5. So how to find it? So let's call the missing value as X. And then we know that if there are 6 values, which there are in this case, including the X, so then we find the median by adding the midpoint, taking the midpoint of the 2 middle values. So in this case, the 2 middle values are 10 and 6. So median will be their midpoint, 10 and X. So the median will be the midpoint of 10 and X, so 10 plus X divided by 2. But we're also told that the median is 11.5. So we'll set that equal to 11.5 and solve this equation for X, and we get 13. Problem. There are there'll be 5 tests in a course. You score 89, 76, 66, 91, and 66, 91, 4 of them. What do you need in the 5th test to have an overall mean? That score of 84. So let's say you need X on the 5th test. So then the overall mean will be obtained by adding the 5 scores, including the X, and dividing by 5. And we want the overall mean to be 84. So 84, and these 4 numbers add to 322. So 322 plus X by 5, and then we solve and we get X is 98. So now this question can be modified sometimes. So you may have a question like, there may be 5 tests. You score, and then you may be given information, let's say, the 3rd test counts twice. So 3rd test counts twice. Test counts twice. Now, what do you need on the 5th test to have an overall mean of 84? So now the 3rd test was 66, so that will actually be counting twice. And that means it will be as if there are 6 tests total. So if something counts twice, that also you write it 2 times in the addition, and you also count it 2 times in the count. So now the total is 6. So, and then you will just go from there, whatever the problem is. So it'd be 6 times the 84, and then you just work out the X accordingly. So I won't do it right now. Right now, 66 was counting only once, and so this was 5. Question: with the same scores in the first 4 tests as above, is it possible to have an overall mean of 85? Or more in the 5th test? Assume the maximum possible score is 100. So let's say you get the maximum possible score in the 5th test, and then you again average out the 5 tests, so you get 84.4. So even with the maximum score in the 5th test, you're getting only 84.4 as an average, so you cannot have an average of 85 or more. Finding missing number if 2 means are known. So problem, you write down 20 numbers and find their mean to be 33. Then you erase one of these numbers and find the mean of the remaining 19 numbers to be 34. What was the erased number? So the rule we used here is that if we want to calculate sum of a certain list of numbers, we multiply the count by the mean. So for the 20 numbers, the mean was 33. So the sum of these 20 numbers will be 20 times 33, which is 660. And then the sum of the 19 numbers would be the 19 times the average of the 19 numbers, which was 34. So that's 646. And to get the missing number, you subtract these two, the sum of the 20 numbers and the sum of the 19 numbers. In this case, we find the missing number to be 14. Change in mean caused by new data. Suppose the mean ACT of 15 students in a high school is 29. A 16th student arrives because of transfer, and this new student has an ACT of 33. What's the new mean ACT of this class of 16 students? So once again, we first find the total ACT among the 15 original students. That's obtained by multiplying the 15 by the average. So that's 435. And now when the 16th student comes, the new total is obtained by adding the score of the 16th student in the sum of the original 15. So 435 plus 33, that's 468. So that's the total for 16 students. So to get the average of 16 students, we divide by the total by the 16. So 468 divided by 16. So the new mean ACT is 29.25. Find the median of unassorted data. So this is an unassorted data. We first arrange it in ascending order. So we see 33 and 36 are in the middle in this case. The median will be their midpoint, which is 34.5. Relationship between mean and median in the skewed data. So in the data that's skewed to the right, mean is greater than the median. We illustrated that by a picture earlier. And this is because the extreme values in the right tail or the outliers, this is because of extreme values in the right tail or outliers with extremely large values. So in the skewed right data, we have outliers with extremely large values, and mean tends to go towards the outliers. If there are extremely large outliers, then mean tends to be large. And if there are extremely small outliers, then mean tends to be small. So therefore, in the skewed left data, median is greater than the mean. This is because extreme values in the left tail. So for skewed left data, the outliers lie in the left tail and they are very small values. Mean is the measure of central tendency that is most affected by outliers. Median, and mode are not affected by outliers. In a skewed data, median is a better average than mean. In a symmetric or nearly symmetric data, mean is usually the best kind of average. Big N is a symbol for population size. Little n is a symbol of small size. So once again, we have the skewed right, symmetric, and skewed left. In a symmetric distribution, mean, median, and mode are equal. In the skewed left, mean is on the left side of median, and in the skewed right, mean is on the right side of the median. And the mode is the value which corresponds to the peak. So this number is the mode in this case, and this number is the mode in this case. You own a business, the annual salaries of all employees, including yourself, are given below. Your salary is the highest, mean, median, and mode. So mean is obtained by adding all of them and dividing by how many they are. Median is the central value, which is 33, and mode is the most occurring value, which is 33. And then business makes an extra income of 20,000 that you decide to divide as a bonus among all employees. Find the mean, median, and mode of the new salary. So the 20 is divided by 8. Remember, salaries are in thousands, so we'll write the 20,000 as 20. So you divide it by 8, you get 2.5. It means everybody gets an extra 2.5 thousand, and therefore the original mean, median, and mode also increased by 2.5 thousand. So you will just add 2.5 to all the original mean, median, and mode. And business makes extra 20,000, which this time you decide to keep for yourself. So when you keep it to yourself, the mean still increases as if you divided it equally, because you're still throwing the same total extra into the mix. So the mean, and the new mean is still the same as you got in the previous problem where you added 2.5 to the new mean, because everybody was getting an extra 2.5. So the mean in this case is still the same as if everybody got an equal share, 36.625. But the median and mode will not be disturbed, because this time the extra 20 just gets taken by this 50. So the 50 becomes a 70. So we still have the same mode as before, 33, and the same median as before, which was 33. So when only one value is being increased towards the tail end, then that does not change the median and mode, but that still affects the mean. And if everybody gets a 5% raise, then the original mean, median, and mode just get multiplied by 1.05. Range of a data is found by subtracting smallest value of data from the largest value. So in this case, the smallest value is 10, the smallest value is 4, the largest value is 10, so the range would be 10 minus 4 or 6. Advantage of range is it's easy to compute. Disadvantage is it's only using 2 data values and ignores the rest of the values. Variance and standard deviation are measures of dispersion which use all data values. Standard deviation is the positive square root of variance. Variance is the square of standard deviation. Variance and standard deviation can never be negative. Example, find the standard deviation if variance is 81. So variance, the standard deviation will be the square root of the variance. The square root of 81 is 9. Example, find the variance if standard deviation is 4. Variance is the square of standard deviation. So it'll be the square of 4, that's 16. Variance and standard deviation are 0 if all values in the data are the same. So for example, if all the values are 4, 4, 4, then the standard deviation, variance, range, they're all 0. Lower standard deviation means higher consistency. Higher standard deviation means lower consistency. So if you have 3 funds which have 3 different standard deviations, then the fund with the lowest standard deviation would be the most consistent. So in this case, fund A will be the most consistent. Find the mean, standard deviation, and variance of the following. So we illustrated how to do it on the calculator. You can just review those corresponding videos here, which show how these are done on calculator. And the calculator does the mean and the standard deviation. So if the sample, when you do the SX in the calculator doesn't do the variance. So you just have to square the SX by yourself to get the variance. Variance is the square of the standard deviation, and mean is the X bar. And then if it's population, then you don't look at SX, but sigma X. Remember, S is for sample, sigma is for population. Population mean and sample mean are the same, so that's why this one is still 3.25 as this, but for population, you have to read at the Greek letter sigma and not at the S. Empirical rule says that 68% of the data lies within 1 standard deviation of the mean, 95% of the data is within 2 standard deviations, 99.7% within 3 standard deviations. Problem, according to empirical rule, 68% of area under the normal curves between nu minus sigma and nu plus sigma. So remember, sigma was the population standard deviation, nu is the population mean. What percentage is between nu and nu plus sigma? So within 1 standard deviation means 1 standard deviation on the left and 1 standard deviation on the right of the mean. So this total area is 68%. They are asking how much is between mean and just one side. So that's just half of the 68, which is 34%. And then they say what's percentage of area that's more than 1 standard deviation from the mean. So within 1 standard deviation, we have 68%. And the one that's outside this range is the one that's more than 1 standard deviation on this side and this side. So that'd be 100 minus 68. So that would be 32. Suppose heights of baby girls a certain age are normal with mean 25 inches, standard deviation 2 inches. Suppose 2,000 girls are sampled. Use empirical rule, find percentage of girls between 19 inches and 31 inches. So first we will change 19 and 31 into z-score, and z-score tells us how many standard deviations. Since we have to use empirical rule, so we have to know how many standard deviations we are talking about. Therefore, to get the standard deviations, we use the z-score. And z-score is obtained by x minus mean over standard deviation. So z-score for 19, remember the 2 values that we are interested in are 19 and 31. So we first get the z-score of 19, that'd be 19 minus the mean. Mean was told to be 25. 25, standard deviation was told to be 3. So 19 minus standard deviation was told to be 2. So 19 minus 25 by 2, that's -3. Similarly, you find the z-score for 31. So that'd be 31 minus 25 by 2, that's 3. Remember, 31 was the second value. We wanted between 19 and 31. And this tells us that we are talking within 3 standard deviations, because you have to note the keyword. The keyword here was between this and this. So between this and this means between -3 and 3. That means within 3 standard deviations, and that we know is 99.7%. And then here they're asking the number of girls between 19 and 31. In part A, it was the percentage of girls between 19 and 31. And part B, it's the number of girls between 19 and 31. So total girls are 2,000. And if 99.7% fall in these two values, then to calculate what number falls, you just multiply the 99.7% by 2,000. 99.7% means 0.997 times 2,000, that's 9094. So that's the number of girls that fall in the between these two ages. In C, they say the percentage of girls with height less than 21 or greater than 29. So you first change 21 and 29 into z-scores. So z of 21 be 21 minus the mean over standard deviation, that's -2, and z of 29 is 29 minus the mean over standard deviation, that's also 2. And so here we are talking between these two, within 2 standard deviations, we will have 95%. So this is the mark on the left, and this is the mark on the right within 2 standard deviations. So we have 95% whose ages will be between these two. But here, and the two numbers were 21 and 29. But the question was the ones whose height is less than 21 or more than 29. So the 95% was between 21 and 29 because it was within 2 standard deviations. If you go less than 21, it's this one. More than 29, it's this one. So again, we have asked to find the leftover after the 95. And the total is 100%. So it would be 100% minus 95% equals to 5%. That basically makes this one who are less than 21 and this one who are more than 29. In the next part, they only ask the percentage that is greater than 29. So they don't ask the less than 21, they only ask the greater than 29. So that will just be half of the 5%. So half of 5% is 2.5%. And then sometimes we may be asked non-symmetric question, the percentage of girls between 27 and 29. So let's first change 27 and 29 into z-scores, and then you will see what I mean. So 27, the z-score for 27 is 27 minus mean over standard deviation, that's 1. And z-score for 29 is 29 minus 25 over 2, that's 2. And so in this case, we are asked between 1 and 2. So this is the 1 standard deviation mark. Remember, in mean is the middle of the normal curve. This is the 1 standard deviation mark. This is the 2 standard deviations mark. So you are asked between 1 and 2. So now, if you remember this picture, you can right away see that between 1 and 2 standard deviations, we have 13.5%. And I had already explained in my earlier video how this 13.5% comes and how this 2.35% comes. So here you can just remember these numbers. So the answer is 13.5% in this case. Problem: weekly study times for college students are normal, mean 20 hours, standard deviation 3, given interval around the mean where 95% of study times fall. So 95% corresponds to 2 standard deviations. So you add 1 standard deviation is 3. So 2 standard deviation would be 2 times 3, that is 6. So you just add the 6 and subtract the 6 from the mean. So mean minus 6 is 14, mean plus 6 is 26. So the required interval is 14 through 26. Also note that a value which is 3 or more standard deviations away from the mean on either side is considered unusual in this course. Weighted mean. Find correct to 2 decimal places the sample mean, standard deviation, and variance of the following data. So in this case, we have a group data. So we first get the midpoints. So midpoints are 12, 17, and 22. And then when we enter it into calculator, as I explained in my earlier video, then the mean is 16.12, sample standard deviation is 3.64, and then we square it to get the sample variance. And then here, so now there's also a way to find this by hand, as I will illustrate in the next problem. So if you don't want to use the calculator function, you can actually do it by hand. So this is done as follows. Find the weighted and unweighted mean. So the unweighted mean, you just ignore the weights and you just consider the values. So the unweighted mean will just be 10 plus 15 by 17 divided by 3, and that's 14. And weighted mean is found, so you can do it on the calculator as explained in the video, but you can also do it by multiplying the values with the weights, adding up the results. So you do 10 times 4 plus 15 times 5 plus 17 times 7, and you divide this all by the sum of weights, which is 4 plus 5 plus 7. So remember to put a parenthesis around the whole denominator and the whole numerator if you want to do it in one stroke on the calculator. And so the weighted mean is 14.625. A student got an A in her 3-hour stats course, B in her 4-hour physics course, C in her 3-hour English course, F in a 1-hour biology, A in a 4-hour calculus course. Assume A has 4 points, B has 3 points, C has 2 points, D has 1 point, F has 0 points. Find the GPA. So we've listed the grades which the students made. So students made A, B, C, and F. And then here we list the points that correspond to each grade. And here we list the hours that correspond, the hours that the students took for each grade. So for the A, we had 3-hour statistics, and then we also had a 4-hour calculus. So we will lump together those two hours for the A, the 3 and the 4. So that's why we have 7 hours of A. Similarly, we list the hours for the other. And GPA is found by adding the products of the points and the hours. So, and then dividing by the total hours. So we'll have 4 times 7 plus 3 times 4 plus 2 times 3 plus 0 plus 0 times 1. So correction. And that should be 28 and 1240, 46 divided by 11, 15, 16. So let's see, 46 divided by 6 and 12, 18, 28, 16. So it's actually 2.88 here. Okay. So next problem in a stats class. Homework counts for 10% of the grade, quizzes count for 20%, midterm 25%, final 45%. A student scores 100% on homework, 95% on quizzes, 84% on midterm, 89% on final. Find the overall course percentage. So here we first list what the students scored in each of the 4 assignments. So and we don't have to do the percentage, just list what it was before the percentage. So the student got 100 on homework, 95 on quizzes, 84 on midterm, and 89 on final. And here we list the weights. The homework weight is 10, quiz is 20, and then 25 for the midterm and 45 for the final. And then we do the same thing. We multiply the scores with the weights, add them up, and we divide by the sum of weights. So we get 90.05%. Z-score, as we said before, are obtained by subtracting the value of interest, subtracting the mean from the value of interest and dividing by standard deviation. And Z-scores tell us, Z-score of an observation tell us how many standard deviations the observation is from the mean. Z-score can be positive, negative, or 0. If the Z-score is positive, the observation is above the mean. If the Z-score and the more positive a z-score is, the more that observation lies above the mean. If z-score is negative, the observation is below the mean. The more negative a z-score is, the more that observation lies below the mean. If z-score is 0, then the observation is equal to the mean. So for example, if you have to find z-score of 55 and mean is 52 and standard deviation is 4, then it would be 55 minus 52 or 4.75. When you're given 4 points with these z-scores, which of these points greatest distance above the mean? So A has the highest positive z-score, so A is the greatest distance above the mean. And which is the greatest distance below the mean? So here you look for the one which has the most negative z-score. C has the most negative z-score, so C is the greatest distance below the mean. Example, mean ACT math in a certain year was 22.6, standard deviation 3.5, mean SAT was 550, standard deviation 51.6. Which score is relatively better, 33 on math ACT or 700 on math SAT? So you find z-scores of both, and whichever has the better z-score is the better score. So for the ACT, it would be 33 minus the mean, which is 22.6, divided by standard deviation, which is 3.5. So 33 minus 22.6 over 3.5. So 2.97 was the z-score for ACT. Similarly, for the SAT, we're interested in the 700 SAT. The mean SAT was 550. Standard deviation was 51.6. And so 2.91. So this tells us that the ACT score of 33 is better than the SAT score of 700. A college will accept only those students whose ACT score is at least 2 standard deviations above the mean. If the mean in a certain year was 22, standard deviation 3.5, what is the minimum ACT score needed to get admitted? So since z-score is the quantity that tells us how many standard deviations we are from the mean, and we are told we are interested in 2 standard deviations above the mean, so z will be positive 2. If it's below the mean, then it would be negative 2. And the mean is given to be 22, standard deviation 3.5, and we are to find the score. So we'll use our z equals x minus mean over standard deviation. And z is 2, x is to be calculated, mean 22, standard deviation 3.5. So from this equation, we see x is 29. So the minimum ACT needed is 29. The mean height of women in the city is 62.6, standard deviation 2.5. Find the heights that are between 1.5 and 3 z-scores. So we are given these 2 z-scores, the 1.5 and the 3, and we are given the mean and standard deviation. So first we will take the z as 1.5 and find the height. That is 66.35. Then we take the z-score of 3 and find the height, and that's 70.1. So when we are talking between 1.5 and 3 z-scores, we are talking heights between 66.35 and 70.1. Mean length of bowls is 13 centimeters, standard deviation 2 centimeter. You want to discard all bowls that are more than 3 standard deviations from the mean. Which lengths will be discarded? So 3 standard deviations from the mean could be on either side of the mean. So you could be z equals -3 or z is 3. Remember, the number of standard deviations from the mean is the z-score. So we will basically substitute z equals -3 and calculate the x. From this formula, z equals x minus mean over sigma. So we got x equals 7. And then we repeat it with z equals 3. And then we get x equals 19. And so therefore, we want the bowls that are between 7 and 19, because those are within 3 standard deviations, and you want to discard the ones that are more than 3 standard deviations from the mean. So you want to discard the ones that are not between 7 and 19, which means those are the ones that are less than 7 or more than 19. Percentiles and quartiles. Your percentile rank tells you what percent of people are below you. Example, if your SAT score has 85th percentile, it means you scored better than 85% of the test takers. And it means 85% people are below you and 15% are above you. Similarly, 10th percentile of newborn babies is 6 pounds. It means 10% of the babies are below 6 pounds and 90% of the babies will be above 6 pounds. 90 is 100 minus 10. Quartiles divide data into fours. Q1 is the 25th percentile, Q2 is the 50th percentile or the median, Q3 is the 75th percentile. For example, if your ACT score was third quartile, what that means is the third quartile is the 75th percentile, so it means 75% people were below you, or you did better than 75% of the test takers. And interquartile range is the difference between Q3 and Q1. Lower fence is Q1 minus 1.5 times interquartile range. Upper fence is Q3 plus 1.5 times IQR. And outliers are those values that are not within the lower and upper fence. So anything that's less than the lower fence or greater than the upper fence is an outlier. So as we discussed in the video, how to find mean, standard deviation from Excel, and you can just review that Excel video again. And remember that in Excel, the command for in Excel, every command starts with the equal sign. You just have to remember that. Box and whisker plot, 5-number summary. So 5-number summary is the minimum, first quartile, second quartile, third quartile, and maximum. So in this picture, this is the box and whisker plot. So minimum is 1, first quartile is 2, second quartile is 7, third quartile is 9, and the maximum is 11.5. And the interquartile range can be obtained by Q3 minus Q1, 9 minus 2 is 7. This is a skewed left because the median is occurring much earlier than the middle of the data. And it's skewed right because median is occurring much earlier than the middle, and therefore mean is larger than the median. Similarly, you can imagine what the skewed right, skewed left will be. In this case, the median bar will be more towards the right than you expect. And if all these 5 points are equally spaced, then it will be uniform. And if they're not equally spaced, but the quartiles are sitting symmetrically with respect to the minimum and the maximum in the middle, then that will be symmetric. Calculate the 5-number summary here. So we need the quartiles, and to get the quartiles by hand, we split the data into 2 rows as follows. So, and we also arrange it in ascending order. And then the first quartile is the median of the first row or the first half, which is 4. And the third quartile is the median of the second row. So it will be the median of this list of numbers, which is 10. And then the second quartile is the median of the original data. So in the original data, if you read this as a complete data, you will see 7 and 8 are in the middle. So the median will be the midpoint of those, or that's the second quartile. So the 5-number summary is the minimum, which is 0, then the first quartile 4, then the second quartile 7.5, then the third quartile 10, and then the maximum. So if the data has an odd number of values, then you cannot split it into equal halves. So in this case, this has 7 values and 6 is the middle value or the median. So in this kind of a situation, you include the median in both the halves. So the first half will be 2, 4, 5, 6. Second half will be 6, 9, 10, 11. And then again, the first quartile is the median of the first half, which is 4.5. Third quartile is median of the second half, which is 9.5, and the median we already said was 6. And then we have to remember that interquartile range is preferred over standard deviation in a skewed data.